artificial intelligence. Okay, because these two are evergreen platforms that every data scientist, big data what's say engineers, DevOps engineers, cloud architects, everyone should learn now. Linux operating systems and artificial intelligence, because team, of course, Linux operating systems, we are already consuming them, isn't it? All of us, are we using mobile phones, Android phones? Android is a flavor of Linux. So already you're consuming Linux for the past many years. What about AI then? We are using Chat GPT. Yeah, are we using Chat GPT? Then you are also introduced to AI. But the thing is, how effectively and efficiently are we using these platforms is what makes the difference. Okay, so there is a position in IT now, prompt engineering. Heard of it? Prompt engineering. What is the job of a prompt engineer? Just to write valid queries in the AI tool like what's a Chat GPT, and get the most what's the effective result. Okay, so these two are pretty important for every what's the IT professional to learn. So that's where you're investing your time, and I highly appreciate your time. You're not what's the investing time for something else. You are investing your time to get a better career in IT. Okay, so yeah, team, I appreciate all of you for joining these sessions, and you are going to definitely get the most out of these sessions. Okay, so the course is structured this way: a Linux administration course. I'm going to take it for 1 month, where in the curriculum we are going to start off with the sections are sorry, it's divided into 3 sections: part 1, part 2, and part 3, where in the first part we are going to learn Linux operating systems, overview of Linux operating systems, history, and so on. Then we'll see how to set up a lab environment, Linux, how are you going to set up, how to run Linux operating systems over cloud platforms. Followed by that, we start off with Linux commands and so on, and we keep going on. So the first part of Linux for the first 10 days you're going to get is the basic Linux, right? And followed by that, we dive into shell scripting, very important, to automate your activities. No matter you're into DevOps or what's a cloud platform, whatever it is, automation is one key area where everyone should, do their repetitive activities by setting automation. So we learn things over here in shell scripting, how to write scripts, how to run multiple commands, in as a script, how to execute scripts, some programming touch I'm going to add to the shell scripts like arrays, functions, loops, and so on. And followed by that, coming to the part 3, it's completely into administration, networking, and automation again. Right? How to install an entire Linux operating system from scratch. Likewise, how to create users, how to run some process management commands, how to enable scheduling in Linux operating systems, install packages, remove packages, right? All those concepts. And towards the end, we start off with networking concepts, understanding networks, and even containerized operating systems. I'll teach you. And finally, how to add your Linux knowledge into your resume, how to deploy your Linux activities into your resume so that your resume looks so professional. Will give you such insights, and will conclude the conclude this course. So this course is structured for 1 month, team. So starting from today, which is the first of this month till 31st, we are going to have complete Linux sessions. And yeah, the sessions are going to happen 6 days a week, Monday through Saturday. Okay, so yeah, team, and few things before we continue get into the actual discussion. So the sessions are mentioned free for you. Yeah, did the management say the sessions are free? Of course the sessions are free, but there is a condition here. The condition is the sessions are free for what's a Naresh IT students. Yeah, Naresh IT students, as well as people who enrolled to any of the courses with Naresh IT. The sessions are free for the first 3 days. Sessions are free for everyone. Anybody can join today, tomorrow, and the day after tomorrow. But effective Monday, the sessions are going to be free only for the students of Naresh IT. Just remember that, team, and try to cooperate with your online and offline management. Yeah, if you enroll, they'll provide you with a link. Effective the next Monday, you can continue the classes, right? Yeah, team. So that's all. I'm done with the introductions and all. So we're good to go. So now Since we are learning something new, effective today, I just want to bring two more discussions up and then we'll dive into the actual discussion. So, whenever you're learning something new, to make your learning process better, you have to adapt two principles, team. 5W 1H principle. Any idea what is 5W 1H? 5W 1H principle. 5Ws అండి. 5Ws. What are they? I already answered 1W. లేదండి, కాదు. No. You got to raise questions like what, where, when, why, who, and how. Yeah, these are the questions that you got to raise when you're learning something new. Okay, so let's say, for example, here we got data scientists. If I ask them what is data science, yeah, because let's say I'm totally out of data science. If I ask one of the data scientists here what is data science, should they answer or they shouldn't answer? They should be in a position to answer, isn't it? Likewise, if I ask a DevOps engineer what is DevOps, should you answer or you should not answer? Definitely you should answer. Let's say if your friend asked you today, once you went home or your hostel, your friend asked, why are you learning Linux? Or what is this Linux thing? Why are you learning it so why are you learning it? అరే ఏదో చెప్తున్నాడు నేర్చుకుంటున్నారా అంటారా వెళ్ళి? Or you say, you definitely give an answer. So that's what, Tim. Whenever you're learning something, first things first, we got to know few questions. We got to understand few things about that particular, that particular area. If you are learning DevOps, what is DevOps? Why DevOps? Where is DevOps used? What is data science? What are the roles of a data scientist? How I can apply my data science knowledge to a company, and what's the benefit it? These are the questions that we got to raise whenever we're learning something new. So we begin off our journey understanding those questions today, applying those questions to a Linux operating system. What is Linux? Where is Linux used? When to use Linux? Why Linux? Who developed Linux operating system? How in real time Linux operating system is going to help us? All those questions we are going to raise. But I'm telling that before me explaining these concepts, you should do your preliminary investigation before you learn anything new. Okay, try to adapt it, team. Whenever you're learning something new, make sure that you put your effort in the first place before you appear for a class. That definitely gives you a lot of confidence when you're already equipped with some knowledge before someone teaches you that, right? Even in real time environments, when you working in your organizations, if at all your lead said that you got to, tomorrow onwards we're going to start off with let's say Google Cloud Platform. Now what should we do? We should know at least some basics about Google Cloud Platform before he explains something to us, right? So these are some of the questions that you got to raise yourself before you learn something, before you're committed to learn something. I'll explain, Jashwant. Is Linux and Unix the same? I'm going to answer those questions. Okay. Next, second thing, to make your learning process better, faster, and efficient, there are few what's the resolutions I'm going to type here, team. If you like them, take a note of them. If not, just ignore them. Okay. So deconstruct the skill. Learn enough to self-correct. Remove practice barriers. And practice 20 hours on the skill. These are the 4 resolutions that you got to take a note of, team. Okay. Deconstruct the skill. Learn enough to self-correct. Remove practice barriers, and practice 20 hours on the skill. Okay. What are these? I'll explain one after another. So we are starting effective today, learning Linux operating system. So what should I do? If I type some commands, like say, I started typing some commands and asking you to take a note of, let's say, top command gives you a list of all the processes, right? ls command lists out all the content. mkdir hello, it is a command that creates a directory. If I teach you this way, what happens? What the hell is this guy doing? That's what the impression you get, isn't it? So whenever we are learning something, what should we do? We have to learn first the basics, then we got to jump into the intermediary concepts, and then we should dive into the expert level concepts, isn't it? So now, no matter whatever the platforms you're coming from, aren't your trainers teaching you that way? If you're learning data science, they're giving you a complete briefing about data science first, and then they're taking you step by step into rest of the areas like exploratory data analysis with Python, right? How to perform EDA over a huge data sets with Python. So that way they're slowly progressing you towards the advanced concepts, isn't it? Even me, when I teach DevOps, what I do, I teach my teams first Linux operating systems, shell scripting, and then I will take them forward into version controlling platforms like Git, GitHub, Jenkins, Maven, Tomcat, Nexus, and so on. So, whenever we are learning something, it's very important that we should first deconstruct the skill, understand the basics. First, we got to know the purpose why we are learning. So, in order you to get the purpose of why you are learning something, what you got to do, you got to first do first a 5W1H team. When you raise these questions, definitely you get the purpose of why you are learning that particular technology. Then what you got to do is you got to apply these resolutions in your learning process. Like what? Deconstruct the skill. Okay, how to or where to get started off. You got to understand what are the basics in that particular subject. You got to prepare and then continue learning in a structured manner. Next, learn enough to self correct. What does this mean, team? Learn enough to self correct. Yeah. So my voice is breaking. Online teams, any issues as such? Gautam says my voice is breaking. Is it clear, team? Others? Yeah, okay. Gautam, please try to rejoin. I think that fixes your challenge. Okay. Yeah. So learn enough to self correct. Ante, say friends, for example, I'm typing a keyword here. Procrastination. Right? So now what happened is, let's say I don't know the meaning of this. I'm reading an English newspaper and I'm struck when this word I came across. Now what should I do? I got to pick a dictionary, identify this keyword, understand the meaning of that word, and should I get back or stay within with the dictionary? I should get back to my newspaper and continue reading it, isn't it? Now what am I doing is I'm taking a decision this way. Since I'm struck understanding this keyword, the next time when I read a newspaper, I should not face any challenge as such. So I'll by heart the dictionary first and then I'll get back to the newspaper. If I do so, what happens? It may take years to what's a by heart the dictionary, and I'm totally out of sync, isn't it? So this way, team, all of us we want to become experts in whatever the areas that we are learning, isn't it? You want to become a DevOps expert, you want to become a data science expert, but when you want to become an expert, you have to make sure that you identify your learning process, learn whatever is required for you, rather than learning everything in that area. Okay, because experience teaches you to become an expert. You cannot become an expert overnight. So, thereby, you set a goal. Let's say you want to become a data scientist. Now, what should you do? As a data scientist, what sort of Linux should I learn? I should learn only that. Because Linux is being used by data scientists, big data experts, right? DevOps engineers, even NASA scientists use Linux, right? So now to become an expert, I should identify what area am I focused, what is my goal. I should learn Linux of that particular, of that particular extent only. A NASA scientist's Linux operating system or Linux activities, a data scientist doesn't require, isn't it? So you got to identify how much should you learn and learn only that. No need to learn every minute concept in the subject that you're learning. That is what makes your learning process faster, right? Next, remove practice barriers. So we attended this class here, and your mind is running towards some cricket match. Are you focused and learning things faster? No. So we got to make sure that we put all our 100% effort when we are learning something. So when you're practicing too, make sure that you stay focused and learn everything in what's a by putting all your blood and sweat in it, rather than what's a learning things by involving in multiple other miscellaneous activities. So remove all your practice barriers, and finally practice 20 hours on the skill. It's actually a management concept. If you learn something and you put your effort into that for at least 20 hours, you gain expertise in that particular area. So these are not my words, team. There is a gentleman, his name is Josh Kaufman. You can Google his name, or you can even do a what's a YouTube search. So you find this gentleman explained he delivered a TED talk. In that TED talk, he explained how you can learn things way much faster and better, right? So he explained them very well. So you can go by Josh Kaufman. Okay, he's author of a book called The First 20 Hours to Learn Anything. So how he gained expertise in learning things faster, he made a video, a TED talk. Post this session, team, I would definitely encourage all of you to go by his TED talk once, so that you get yourself some idea about how to learn things faster, right? All of us learn things, but what is making us stay outside the box? There should be a difference, right? There are hundreds of students learning DevOps, thousands of students learning data science, but what is the difference between you and them? Some of them are learning and just leaving, but are you also falling into that category, or do you want to learn and make something valuable out of your learning process? If you really want to do something, if you really want to make an impact out of your learning process, what should you do? You have to learn it so effectively and efficiently. So always ensure, team, when you're learning something, raise these basic questions. Get what is the purpose of you learning that particular subject. Yeah, by these questions you get a result. What is the purpose of me learning that particular subject? You get some quick idea. After that, when you take a decision to learn that, make sure that you apply these four basic principles to enhance your learning process and to speed up your learning process. Okay, these are just managerial concepts, team. Since we are learning something new effective today, I just want to bring this forth. Okay, if you find them interesting, take them. If not, just ignore them. Okay, so let's get back to the subject. Now let's raise questions like the 5W1H over Linux operating systems. So what is Linux? Yeah, team. What is Linux? Yeah, Debashish and others again saying this course is free for all existing Naresh IT students. And for the next 3 days, it's free for everyone. But effective Monday, the course is only for enrolled students, regardless of any batch. Okay, if you're Naresh IT student, that's it. You're eligible to join this course, right, team? Okay, yeah. So now I'm getting responses. What is Linux? Linux is an operating system. Now again, let's take this question forward and ask, what is an operating system? What is an operating system? Mm-hmm. Mm-hmm. Okay, so should we say operating system is a system software? An operating system is nothing but a system software to interact with your hardware resources. I'm just simplifying things. A system software to interact with your hardware resources, isn't it? Now, if I purchase a laptop and there is no operating system at all, is it possible for me to open my webcam? Is it possible for me to access Facebook? No, because even though I have hardware resources, in order to interact with them, what do I need? I need a system software that is nothing but an operating system. So Linux is an operating system, right? Now, what are the different operating systems that we know, team? What are the different operating systems that we know? Of course, Windows, our dear friend, right? Windows is our dear friend. Windows. Next, Unix operating system and Linux operating systems, right? I'm just talking about the families, Windows family of operating systems, Unix operating systems, and Linux operating systems. These are the three operating systems available in this world. Again, in those families, we find hell lot of variants. Like Windows, we got Windows 7, Windows 8, Windows 11, Windows 10, right? Again, in Windows server level operating systems, we have different Windows 2006, 2016, 2008, and so on. Coming to Unix, we got HP UX, Sun Solaris, Mac OS, and so on. Coming to Linux, hell lot of them. Even you and I can create our own Linux operating system, right? So coming to Linux, there are hell lot of Linux operating systems available in the world. Thousands of variations of Linux available. Okay, but in order to understand all that, first we should know the history of Linux operating systems. Likewise, we should understand what exactly is an operating system and how operating systems actually function, team. Okay, so let's try to understand that. Over here, I'm going, yeah, Santosh. Any questions, online team? Are we facing any challenges? Can you please tell how much data science aspirants should know? For sure, Aniket. We'll get to know this entire course, I would say. This entire course, if you learn, that is definitely sufficient for your data science activities, right? Yeah, so now over here, let's say this is the hardware layer. This is a hardware layer where I got resources like a CPU. Yeah, what falls into hardware? CPU, storage, hard disk, memory, right? And other peripheral components like your keyboard, mouse, and so on. They're all falling into the hardware layer. Now, me as a user, if I got a bunch of hardware resources, I cannot directly interact with them, isn't it? So in order to interact and consume these hardware resources, definitely I need a software. And that's where we got, an operating system installed on top of every hardware resources. And we said here we got multiple operating system types like Windows, Linux, and Unix operating systems. Any operating system for that matter, the main goal of an operating system is to make sure that you as a consumer, you're consuming the hardware resources and getting your job done. Okay. Now team, on top of the operating system, what you do, you install some softwares. What are those softwares? Like say Google Chrome. Chrome is one software. Yeah. Next, to prepare your resume, what software do you use? MS Word, right? MS Word. Likewise, say this WebEx software. To host the meeting in my machine, I got WebEx software installed. What are all these softwares termed as, team? Operating system is a system software, but what about the other softwares that I'm talking about? Application softwares, very good, very good. These are all termed as the applications that I run over my operating system. These are all termed as application softwares. Yeah, please. These are all termed as application softwares that are consumed by a user. Now, team, these are all application softwares. Now, do these application softwares need CPU, storage, memory, and so on? Yeah, do these resources, application softwares require hardware resources? Yes, then how are they consuming the hardware resources? He said an answer. What is it? An operating system is going to help these application programs to interact with the hardware resources. That is where, team, now we got to understand one core component between the hardware resources and the operating system, which is called as a kernel. Okay. Every operating system, be it Windows or Linux or Mac OS, whatever it is, every operating system has a core component called a kernel. And this is the guy that interacts with the hardware resources. Now, let's say you prepared a Word document, your resume, and you want to print your resume. Now, let's say at this hardware layer level, there is a printer attached to your laptop or whatever. Now, how your Microsoft Word is going to, send instructions to this printer and print the document. It's not talking directly. This Word application is not talking directly to the printer. But what happens? It raises a request to the operating system. Operating system talks to the kernel, and kernel checks whether this printer is available or not. And then what happens? Kernel assigns the resource to OS, and from the OS, it's assigned to the application. If the resource is available, then you find your document getting printed successfully. If the resource is not available, at the application level, you're getting a response. Let's say the printer is busy, or maybe the printer is not connected, something like that. Yeah, team. So, yeah, team, online candidates, what happened? My voice is breaking. Wow. No, no, not required. Any language, sorry, any programming language? No, not required, team. Not required. Okay, fine. So now this is the overall structure we got to understand whenever we are interacting with our what's say laptops or what our desktops. How things are happening. We got a hardware layer. We are not interacting with the hardware layer, but we are interacting with the operating system. So now a simple definition of an operating system is nothing but an operating system acts as a bridge between user of the computer and computer hardware. Yeah, the definition of an operating system is nothing but a system software that acts as a bridge between user of the computer and computer hardware. Now, what about kernel? What about this kernel thing? Yeah, let's keep a definition this way. The definition of a kernel goes this way. A kernel is nothing but a core component in an operating system that acts as a bridge between the operating system and hardware resources. A kernel is nothing but it's a core component that we find in every operating system. Windows operating system has a kernel. Linux operating systems do have a kernel. Even our mobile Android phones do have a kernel. Okay, so this is what Tim. User interacts with the operating system. Operating system interacts with the kernel to reach to the hardware resources. Right? So these are the two definitions for an operating system as well as a kernel. And now any operating system you take, Windows or Linux or Unix operating systems, they are fulfilling the purpose of a user to interact with the hardware resources and for the user to install his respected application software. So, are we clear, team? Are we following? Yeah, friends, any questions? Online, offline team? Are we following? Yes. Okay, so this is kernel and this is a quick overview of an operating system. Now, coming to the operating systems, we all know and we are all well versed with one operating system, which is Windows. And so, when we already know Windows, then why should we learn Linux operating system? Why a data scientist should learn Linux machine? Windows operating systems not reliable. Okay. సో ఏదైనా ఒక టెక్నాలజీ మనం నేర్చుకుంటున్నామంటే ఆల్రెడీ వి నో సంథింగ్ if you are learning something new, it means the existing machine has a fault, isn't it? Now, what are the faults that you found in Windows operating systems? Yeah. So he said not reliable అండి మీరు ఏమన్నారు? You lost you only because of Windows. Okay. Yeah. You said what is the reason? Not rel Mhm. Okay. 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 It gave up. Okay. Fine. So, okay. Okay. Got it. Got it. So now, team, what I would say is my laptop contains Windows operating system. I'm using Windows. So as a consumer of Windows, I'm not going to blame Windows. Okay. Because I'm already consuming it. Right. If I'm totally not consuming it, I can, of course, there are some challenges with Windows. We'll address them shortly. But for now, let's take this perception. Why should we learn Linux? Let's take the advantages of Linux. I'll talk about Windows too, but first, why should a DevOps engineer learn Linux? Or why a data scientist you think should learn Linux operating systems? Yeah, you tell me what are the reasons? Linux operating systems are mm, open source. They are free. Okay. Second thing, they're very best for multi-user and multitasking. They are reliable. They keep running for years. More secure, right? More secure. So I'll give you a quick example so that you may get some idea about why Linux operating systems team. Okay. So how many of us are aware of this rover? How many of us are aware of this rover? Where is it now? To our nearest planet, Mars, right? NASA deployed this rover long ago. It's more than a decade, right? Yeah, please come, please come. It's more than a decade that this rover is deployed onto Mars. And scientists are communicating with it. They're giving instructions to it to take pictures and send the information back to the the ground station. And yes, even today, of course, it's now in trouble though, but still, even today, what's happening? It's responding back to the queries that scientists are writing and sending to it. Now, these hardware resources, they are not running on their own. They are being given instructions, okay, and all those instructions are being received, processed, and then the rover is turning left or right, front or back, and so on, taking pictures and so on. Now, in order that rover to do all those activities, the hardware resources, in order to function, there should be an operating system required, isn't it? Now, what operating system is running? If you do a research, you find the operating system running here is a Linux operating system. It's almost been more than 10 years, and continuously that rover is equipped with Linux operating system constantly running. అంతవరకు వెళ్ళక్కర్లేదండి. Let's say our mobile phones. All of us we are using Android phones. How many of you are switching off your mobile phones? Yeah. Are we turning off our mobile phones? I mean, today, after you go home, you shut it down. And in the morning, you start it again. No, we keep on running the operating system. Sorry, we keep on running the mobile phone. And what's happening? What's happening? You're not facing any challenges with your mobiles, even though the operating system is constantly running, right? So there are areas where we want operating systems to run continuously for a long time. In such areas, you find Linux operating systems giving its absolute best, right? And multi-user and multitasking. What does that mean, team? Now, say for example, there is a server. Let's talk about HDFC Bank here. Let's say this is a central server of HDFC Bank, where there is this net banking application configured, right? Now we as customers, what we are doing, we are connecting to this net banking application and doing our transactions. Now say for example, if Kumar is doing a transaction, should I wait? Yeah, should I wait if Kumar is doing a transaction? Until Kumar completes his transaction, I should wait, or I can do simultaneously. Simultaneously, right? Multiple users are connecting to that server and carrying out all their operations simultaneously, because This server here is equipped with an operating system that supports multi-user and multitasking feature. Right? So Linux and Unix operating systems are proven to give their best in multi-user and multitasking activities team. So coming to Windows machines, yes, Windows operating systems too do support multi-user and multitasking, but they need more CPU, more RAM, more storage. Windows operating systems require more CPU, more RAM, and more storage. And of course, they are what say licensed. Licensed. You got to purchase licensing. You got to pay money for them. And second thing, Windows operating systems are of two categories. One is desktop versions. If you go by a desktop version or what's a PC, what's happening that is not supporting multi-user multitasking. You have to purchase a server level Windows operating system. When you purchase a server level Windows operating system, that's costing you more and more. Right, team? So thereby what's happening? You got to invest a lot, not only in terms of hardware, but also operating system and so on. But coming to Linux, Linux systems are are proven to give their best in continuous long running activities. They're open source, reliable. They keep on running for a long time, and they're very, very secure. Yeah, team, they're very much secure. But Windows, coming to the security part, at some point of time, you can easily, crack a Windows machine. You can easily crack a Windows operating system and gain access of it, right? So I'm just talking about the challenges of Windows. I'm not saying Windows is, I'm not saying Windows is too worse, but to some extent, when we are running some real-time applications, if we want to get benefited, it's better to rely on Linux operating systems rather than Windows. Recently, you saw this. You went through news, right? Windows operating systems experienced a blue screen of death. Yeah, the screen of death. Lot of airports they stalled with this challenge, isn't it? It didn't happen the last time. It didn't happen the last month. It even happened several times. Windows experienced such challenge several times, and even there are instances where Mac OS or Apple made fun of Windows operating systems. Back then, back in 2016 and 17, even during that time, what happened? The entire global Windows operating systems they stopped, and at that point of time, Mac started making fun of Windows operating systems. I mean, Apple they started making fun of Windows operating systems, right? So this way, when we talk about Windows operating systems team, what happens is you find when you want to run an operating system for a long time, you find Windows operating systems not giving their absolute best. That is the reason now what's happening when we talk about mobile phones, we're finding only Android phones in the market. Of course, Android is a flavor of Linux operating system. You're finding Android phones and what else, team? iPhones. What are the two mobiles that you're finding mostly? iOS and Android. Why not Windows? There were Windows phones too, right? Back in the past, there were Windows operating systems too, meaning Windows phones with Nokia Lumia phones, right? And even Windows collaborated with, I believe, some other companies too, Nokia, Siemens, and there are different companies with with which Microsoft collaborated. But what happened now? There are no Nokia Lumia phones anymore. Yeah, team. Why is that? Because customers started facing a lot of challenges when the operating system is running continuously and Windows is not, giving its best. A lot of lag issues. Thereby, what happened? People started off discarding Windows mobiles, and now we are finding only two mobile phones very popular in the industry. What are they? Android phones and iPhones. That's it. Okay. So now, yeah, team. One of you raised a very important question, which is What is the difference between Unix and Linux operating systems? Okay, so let's get back into history and let's try to understand what exactly is Unix and what is Linux. We came to know about Windows operating systems, right? So far we discussed about Windows. Let's now talk about an operating system which is Unix. Yeah, team, Unix operating system. So back in 1970s, back in 1970s, the computer scientists, they were looking for an operating system that supports multi-user and multitasking nature. They were looking relentlessly for an operating system that supports continuous long-running activities. And to fulfill that requirement, when they were researching, they came with developing an operating system called Unix. Okay, so the birth of Unix happened in Bell Labs of USA, USA, and it was born back in 1970s. And the problem with Unix is the operating system. Yes, of course, it came up with best features like multi-user and multitasking. It came with multi-user. Multiple users can connect to a Unix machine at the same time. Multitasking is also supported, and it's robust, secure, and what else? It's robust, secure. It keeps on running for a long time, continuous running. It supported all those features, but the problem is Unix runs only on some specific hardware. Unix operating systems run only on some specific hardware. They created few operating systems like HPUX, Hewlett Packard. They developed their own operating system, which is HPUX, that runs only on Hewlett Packard specific hardware. Sun Microsystems, they created their operating system, which is Solaris, that runs only on Sun Microsystems hardware. IBM, they created their operating system, which is AIX, that runs only on IBM specific hardware. And in the current generation, we have Mac OS running only on, running on, it's Mac runs on my Windows laptop, sorry, my HP laptop. No, in order to get a Mac operating system, I should purchase Apple hardware, MacBook, right, team? So now the problem with Unix is this: operating systems are very secure, robust. They have all these awesome features, but the problem is they run only on that specific hardware only. If you want an operating system with a multi-user multitasking feature, you should also purchase the hardware. That's the problem. So thereby what happened, by the name Linus Torvalds, some guy by the name Linus Torvalds, he started off, his research identifying why these Unix operating systems are running only on that specific hardware. Shouldn't I make these operating systems run on other hardware types? And he started off experimenting, and he adapted Unix operating system, and he started off, writing code for Unix kernel. He started experimenting at the kernel level. Remember, we discussed about kernel before. What is kernel, team? What we said, a core component in an operating system that acts as a bridge between the operating system and hardware resources. So now the Unix operating system's kernel is made proprietary to run only on Unix specific hardware. So thereby, now what happened is, DevOps class. Okay. Okay. So what happened is here, Linus Torvalds adapted this kernel and he started experimenting on, that kernel. Let's say if this is, let's say HPUX kernel, this HPUX kernel is letting the instructions run only on HP hardware. So now he started experimenting on it, and he started making modifications to that kernel so that that kernel can send instructions to any hardware type. That kernel can send instructions to the any hardware type team. So that is how Linux kernel was born. That is how he started. He was successful in making the Unix kernel to run on any hardware type. And what he did is he named that kernel as a Linux kernel. Okay, so Unix operating system's kernel runs only on Unix specific or that vendor specific hardware, whereas a Linux kernel runs on any hardware type. Right, Tim? And the beauty is he made that kernel available to the users across the globe. He made it open source. అంటే అతని పేటెంట్ తన పేరు మీద పెట్టుకోకుండా వాట్ హీ డిడ్, he dedicated it to the world. He made it open source, meaning you and I, we can adapt that kernel and create our own operating system out of it. So since Linus Torvalds made this modification and he contributed only to the kernel, we cannot term Linus Torvalds as the inventor of Linux. మనం ఈ ఇన్వెంటర్ అనలేమండి. He did not invent an entire operating system. He adapted from Unix and developed Linux kernel. So we are going to term him as a contributor to Linux kernel. Invention ki discovery ki తేడా ఉంది కదా. Yeah. What is invention and what is discovery? Columbus discovered the route to America. That's what they say. Meaning already there is a route, but he identified it. He is the first person who identified that. Invention ki example చెప్పండి. Yeah. Creator. Now who invented telephone? Graham Bell. Graham Bell invented telephone because it's not there, he created it. Whereas in discovery, it's already there, but he is the first person who identified it. So similarly, Linux operating system, he is not the father of Linux operating system from scratch. He adapted it from Unix and made a core component called kernel. Thereby we are calling him as a contributor who contributed to Linux operating system by developing something called a Linux kernel. Yeah, team. So I hope you got some idea about this session today. What exactly is an operating system? What is a kernel? And few concepts about Linux. Right, team. So we got 29 more days to discuss about all these. I'll speed up the classes as we progress. Okay. Since these are the first initial sessions, we are going a bit slow, team. Understanding all the history, we're taking steps a bit slow, but I'll make sure I will speed up the classes as and when required. Okay. Yeah, so let's wind up for the day and continue tomorrow. Tomorrow's session will talk few more things about Linux file system and setting up Linux environment for our practice. Yeah, team. All right, friends, I got a DevOps class now, so my students are waiting, so let's connect tomorrow. Yep. Thank you, everyone. Thank you for your time. Yeah, the sessions are only for 1 hour, team. Well, Amarnath, you can check with our management. I'll have a word with the management too about the recordings. So I'm not sure of whether you're going to get the recordings or not.